Today I'm going to walk you through how to do calculations with intensity and sound level. Because it involves logarithms, students often find this confusing. So what do we mean by intensity? Well, the intensity is the energy per time, which means the power, so watts, per area, and area is in meters squared. So if you look at the table there on the left, you can see that the intensity of various sounds that we hear, like the rustling of leaves, is 1 times 10 to the minus 11 watts per square meter, all the way up to a jet plane, which is 100 watts per square meter. Those numbers vary by an awful lot, and it's sort of hard for us to wrap our brain around the intensity. We can hear from the very lowest sound that a good human ear can detect is 10 to the minus 12 watts per square meter, all the way up to 1 watt per square meter without feeling pain. If you get close to a jet engine, you might blow your eardrums. The loudness that we hear in the detectors in our brain is actually related to the logarithm of the intensity. So it goes up by powers of 10. So we talk about the sound level, which is measured in decibels, where the sound level in decibels is 10 times the logarithm of the intensity of the sound divided by the intensity of the lowest sound that we can hear, which is 1 times 10 to the minus 12 watts per square meter. And the symbol we use for sound level is a beta, and the unit is decibels, which is small d for deci and a capital B for bells. So the sound level in decibels ranges from 0 for the threshold of hearing all the way up to 140 for a jet plane at 30 meters. So a number between 0 and 140, that's something that's easier for us to wrap our brain around rather than comparing numbers that are in powers of 10. We also know that when you get further away from something like a speaker or a jet engine, the sound level decreases. And it turns out that as you go away with distance, the intensity, which is the power per area, also decreases because the area over which the sound is spread increases. How does it increase? Well, the sound goes out in a sphere, and the surface area of a sphere is 4 pi r squared. So the intensity decreases as a factor of r squared as you move away from it. The intensity is actually, if you look at the equation there at the top right, related to the density of the air, the speed of air, the frequency of the sound, and also the amplitude of the sound wave. So there's a lot of things that go into the intensity, and we won't be talking about that here. So let's just do a quick review of the properties of logarithms. So remember, if you do the logarithm of a product, logarithm of a times b is the sum of the logarithm of the individual things in the product. So it's log a plus log b. Logarithm of a quotient, log a over b, is the log of a minus the log of b. Why is that? Well, because 10 to the x plus y is 10 to the x times 10 to the y, and 10 to the x minus y is 10 to the x divided by 10 to the y. So since the sound level in decibels is the log of a quotient, 10 log of I over I0, it's going to be basically 10 times the log of I minus 10 times the log of I0. And remember, the log of 10 to the x is just x, so you're pulling the exponent down. So if I take the log of I0, which is I0 is 10 to the minus 12, the log of I0 is just minus 12. Okay, so if I do I over I0, let me rearrange this. Hang on, give myself a bit more room. I need to erase what I just did. Okay, so if I want to find the intensity, so if I'm given a sound level and I'm asked to find what the intensity is, I'm going to rearrange that equation. So I want to get that I out of the logarithm. So the first thing you do with anything is in an argument is you get the whole function that it's in the argument of on one side by itself. So I would do beta over 10 is equal to log of I over I0. Okay, so what's the next thing that you do? Next thing you do is you do the opposite of the function. So what's the opposite of a logarithm? It's 10 to the x. So I will do 10 to the x on both sides. So I'll do 10 to the beta over 10 is equal to 10 to the log of I minus I0. If I do that, it just pulls out the argument. Okay, so that's how I got to this bottom line in the equation, that I over I0 is equal to 10 to the beta over 10. So now to get I is just I0, which is 10 to the minus 12, times 10 to whatever beta is, that's the sound level, over 10. And we'll do some examples in a minute. Okay, so what does that mean? If whenever I increase my value of beta by 10, that increases the intensity by a factor of 10. So if I go from 100 decibels to 110 decibels, the intensity actually increases by a factor of 10. If I went up by 20 decibels, if I went from 100 to 120, the intensity actually increases 100-fold. And if I increase by 30 decibels, it increases the intensity by 10 to the 3, which is 1,000 times. So let's do some practical calculations. First, let's calculate what the intensity, that's I, and the sound level, that's beta, are for a 1 watt source at a distance of 3 meters away and 6 meters away. So the two equations we have so far is that the intensity is power over area, so that's power over 4 pi r squared, and the beta is equal to 10 log I over I0. So I want to calculate I and I want to calculate beta. And what do they give us? They give us that it's a 1 watt source. What does that mean? Well, look at the units. Watt is for power. So that must be the power of the source. And I'm told a distance of 3 meters for part A and a distance of 6 meters for part B. So for part A, I know power is 1 watt and R is 3 meters, so I can just plug those into the equation for the intensity. So the intensity is the power 1, let me write it down, P over 4 pi r squared, so that's 1 over 4 pi times 3 squared. I'm going to get a small number, 8.842 times 10 to the minus 3, and the units, watts per area, so watts per meter squared. Okay, so that's the intensity. What's the sound level? Well, beta is equal to 10 times the log of I over I0. So I've just found my I. What's I0? I0 is a constant. I0 is just 10 to the minus 12. Okay, so beta is 10 times the log of I over I0, 8.842 times 10 to the minus 3 over 10 to the minus 12. And if I put that into my calculator, that logarithm, I get 9.94. So then I multiply by 10, and I get 99.4. And what's the unit? It's a decibel. Okay, so that was just basically plug and chuck. All right, part B, the only thing that's changed is I've moved my R to 6 meters. So if I go to 6 meters away, I'm twice as far away. I should get quieter. How much quieter should I get? Well, the intensity goes as 1 over R squared. So if I go twice as far away, the intensity should go down by a factor of 4. And if I do the calculation, that's indeed what I get. I get 2.221 times 10 to the minus 3 watts per square meter. So it's 2.421. watts per square meter, and the sound level is 10 times the log of that intensity over I0. So we're going to do the same thing we did, 10 times the log of 2.421 times 10 to the minus 3 over I0, 10 to the minus 12. And if I do that logarithm, I get 9.34 times 10 is 93.4 decibels. So if I compare those two sound levels, you can see when I move twice as far away, the sound level decreased by exactly 6 decibels. And that's always the case. So if you go twice as far away, the sound level will go down by 6 decibels. So every time you move 2 times further away, the sound level is going to go down by 6 decibels, and the intensity is going to go down by a factor of 4. All right, let's do a calculation that's not quite so easy. What's the power of a speaker that has a sound level of 120 decibels at a distance of 2 meters? Okay, so we've got the same two equations. Now we know the sound level, so that's beta, it's 120 decibels, and the distance is 2 meters, and I want to find the power. All right, so I've rearranged the equation. You can see it there in blue, doing the algebra that I had on the previous slide. But remember, that's just beta is equal to 10 log I over I0. You should be able to rearrange that. I won't give you the intermediate equation on the test that the one that's circled there in blue, I equals I0, 10 to the beta over 10. Make sure you know how to do that, or if you don't know how to do it, memorize that equation, because this is a very typical problem to show up on a test. Either one of these two problems that I'm doing, so either this one or the previous problem, you need to make sure that you can do both of those. All right, so I'm going to find my intensity. Why would I find my intensity? Well, I want to find the power, right? So I know the power. So I want to find the power. I know the R. I need to find the I if I want to find the power. So I can use this equation to find I and plug it in there. I know R, and then I can find P. So it's sort of a two-step process. So I is equal to I0, which is 10 to the minus 12, times the log of beta over 10. Sorry, times 10 to the beta over 10. Okay, and beta is 120. So that's 10 to the minus 12 times 10 to the plus 12. Right, 120 over 10 is 12. So 10 to the x times 10 to the minus x is just 10 to the 1. So it's 10 to the 0, which is 1 watt per meter squared. So my power, so my intensity is 1 watt per meter squared. Now I need to find the power. So I've got I is equal to P over 4 pi r squared. If I want to rearrange it to find P, I need to take the denominator and multiply it up. So P is equal to I times 4 pi r squared. And I've just found I is 1 times 4 pi, and r is 2 meters. So I get 50.26. And that needs to go to two significant figures. So 50, and what's power? Power is watts, energy per time. So the intensity is 50 watts. What happens if I double the number of speakers? Right, so I've got one speaker with a certain power. What happens if I double the number of speakers? Or sometimes you'll see a problem where you've got one kid yelling and then suddenly you have two kids yelling. How does the intensity change? Well, if I double the number of speakers, I goes to 2I And how does the sound level change? Well, the sound level goes up by times log of 2. So it goes up by a plus 3 decibels. If you move 2 times as far away from the speaker, how do the intensity and sound level change? Well, we just talked about that. The intensity drops by a factor of 4, and the sound level beta goes down by 6 dB. So every time you double the intensity, you go up by 3 dB. Every time you move twice as far away, you take your intensity down by 4, which means it goes up. So the sound level goes down by 6 decibels. All right, so the problem I want you to work on is one where you have to do basically all of the steps that I did in those previous problems. So first of all, you've got fireworks that you know the sound level at a distance of 1 meter. And then I want you to work back, find the intensity and the power, like I did in the previous problem. And then once you know the power, I want you to figure out what sound level, that's beta, do you hear 100 meters away, and what sound level does your friend hear 500 meters away. If you can do this problem, you should be able to do anything that you see on the test.